So with the birth of new Ryzen CPUs, along comes the X470 chipset. Think of it as an optimized refresh of the previous generation X370 boards to get the most out of these new CPUs. If you haven't watched my review of the R7 2700X yet, I would highly recommend you go and watch that first. But to sum everything up, the 8-core 2700X is a nice boost over the previous generation Ryzen 7 processors. My retail part here is capable of an overclock of around 4.3 GHz, and that is a ton of power being drawn over all 8 cores when it comes time for intensive workloads. Seeing as this is my first X470 motherboard review, I want to make it clear that the X470 chipset is mainly targeted towards those who are planning on pairing it with one of the two new Ryzen 7 parts, either the 2700 or 2700X. In the reviews coming up, these boards will often seem at times that they're a bit overboard in certain areas, but remember they are targeted towards overclocking and squeezing as much performance out of the chips as possible while providing a stable experience over the course of years. The board that we're going to be looking at today is MSI's X470 Gaming M7. It's their flagship X470 board that I've had for about 2 weeks now, and it's actually what I completed the majority of my testing for the 2700X on. The board is definitely one of the pricier boards on the market at $259 and today I'm going to share my thoughts on it as well as some overclocking results. It features a neutral design, built-in Wi-Fi, and a very strong 12+2 phase VRM layout, which we'll be taking a look at a little bit later. I definitely enjoy MSI's direction over the last couple of generations for a neutral design approach, but if I'm totally honest here, I would have liked to see a little bit more design flair when it comes to the aesthetic here. After all, this is their flagship board, and it does look a little too plain in my opinion when standing next to other flagship options. RGB is fairly minimal here, which I'm sure some of you may prefer, only on the I/O shroud and behind the right side of the board as we usually see, and as you'd expect, they are fully customizable via MSI's Mystic Light software. There's a cover for the two M.2 drive slots with thermal pads underneath, and up to 2280 in size is supported here. Now, taking a look at the bottom right, we've got a couple of interesting features. The power and reset button here made my job 10 times easier when working with the board on an open test bench during the 2700X testing. We've got a postcode display, which is handy, and we've got an OC dial here as well, which can overclock any Ryzen CPU that you install from 7 different settings. I didn't get a chance to test this one out as I was pretty crammed for time with the 2700X testing, but if you are going to be spending this sort of money on a motherboard, I'm guessing you want to tinker with a little bit of manual overclocking anyway, as that's going to be the best way to find the optimal settings for your particular CPU. For I/O, we've got a decent amount of options here, 4 USB 3.1 ports, 2 2.0 and 2 3.1 Gen 2 ports, 1 Type A and 1 Type C. We're also getting killer LAN, Intel Wi-Fi and HD audio via the Realtek ALC 1220 codec. And lastly, clear CMOS and BIOS flashback buttons are always appreciated if your overclock does not go to plan. Now, the thing that this board does best is overclocking and also managing VRM temperatures under heavy load, since we've got the power split up over 12 phases for the CPU V-core. So let's take a closer look. The MOSFETs being used are the onsemi 4C029 for the high side and the 4C024 for the low side, and this is being controlled by the IR352001, which is a controller that's capable of 8 PWM signals. And since you'll notice there are 14 phases in total here, there is some PWM phase doubling happening here with the IR3598s, which you can find on the back. These take a single PWM signal and split it so that it's 180 degrees out of phase of the original signal. And to basically summarize this, we are getting 2 separate PWM signals from just one signal that's coming from the controller. So in a way, it is comparable to if you were using a true signal for each phase, and we're not losing any benefits of voltage ripple stability here by using doublers. So just to recap, the controller is running in 6+2 mode with 6 true signals that are being doubled to create 12 phases for the CPU V-core, and then we have 2 phases left for the SoC. The max overclock I was able to hit here with my retail 2700X was 4.25 GHz at 1.425 volts with memory speeds at 3200 MHz. This was about 10 millivolts better than the Gigabyte Aorus Gaming 7, which features a 10+2 VRM phase design, which we'll be taking a look at in another video. And to give some perspective, a standard B350 board like the Asus Strix had 4.25 GHz stable at 1.45 volts. Taking a look at the heatsink for the MOSFETs, we can see that heat dissipation has been considered here, and gladly we're not just getting a solid block. I didn't get the time to test VRM temps under full load, but I do have temps here with the 2700X at stock, and here the 2700X was boosting to 3.95 GHz and sitting at about 1.27 volts. After a 15-minute stress test in Prime 95, we don't see the VRMs getting too much hotter than 75 degrees C. I will be sure to add in the overclock temps in an upcoming comparison though, but for now I'm pretty confident that they're doing pretty well. And keep in mind this was on an open test bench with zero directional airflow. And so all in all, I'm pretty happy with the performance that we can squeeze out of the X470 Gaming M7. If you're looking for a board that can take your 2700 or 2700X to its limits, then this is one that you should definitely consider. As always, I'm interested to hear what you guys think of this board down below, and also let me know what X470 motherboards you'd like to see reviewed on the channel. As always, thank you so much for watching, and I will see you all in the next one.